Good morning, everyone. My name is Azam Basha. I have 15 years of IT networking experience. I hold 18 certifications in Cisco, Juniper, AWS, F5, NVIDIA. So today we're discussing about SD-WAN. So this is the demo class, weekends only, and this is going to be for a duration of 2 months. So let's first understand why was WAN, wide area network, redesigned. Okay, so basically all the companies are looking for, or should I say, the shifting from a network centric model to a business intent based WAN network. So what exactly is that? So the network centric model. So network centric model is the model that is specifically focusing towards the network components. For example, your routers, switches, right? Whether L2 or L3. So how are the devices connected? And what is the productivity we can get based on the connectivity? So the focus was never in terms of the applications, right? So you're supposed to connect one server to another server, and you would have a router or a switch connected like this, right? And the only focus was to connect them. And how was the focus? The focus was based towards your networking devices. So how should we connect the devices? How should the connectivity happen? How should the cabling happen? So no one was thinking specifically in terms of the software level. Okay, when I say software level, basically no one were thinking about the applications that were hosted inside the server. Okay, as the network engineers, we were concerned only about the connectivity part. However, now the times have changed. The times have changed, and now everyone is looking for business intent based network. So everyone is focused towards how their applications are, or should I say, can run better. How can their applications requirement is fulfilled with their network? Okay, so that is one of the requirement for, actually that was one of the need why we were supposed to, or should I say, the vendors started rethinking about the wide area network. A key challenge for network operation team is effectively supporting both the new and the existing applications on the WAN. So the old applications usually they were hosted on premises, right? So they were hosted on premises. So what is exactly on premises? On premises is applications that are hosted inside your data center, right? So inside your uh, own premises, right? Your own company. So that's called as on premises. So there's another flavor which is hosting over the cloud. Okay. So now many people opted to also host their applications over the cloud, right? So now then there became a divide. So what was the divide? The divide was divide between the application hosted on premises and applications that were hosted on the cloud. Okay, and then especially considering their sustainable bandwidth consumption and sensitivity of various bandwidth qualities such as jitter, loss, and delay, right? So if the applications are hosted in different data centers, if they are hosted in on premises, or if they are hosted on the cloud, or if they are hosted in some other data center, or a user is trying to connect to that application which is far away, for example, geographically far away, like the user is in India, the application is in US, at that time, basically you will have to actually curate accordingly. So in the traditional networking, we used to have different data centers. However, now with the with the advent of cloud, so we do not have different data centers. So we have on premises and then private cloud, then we have a shared cloud, and then we have a public cloud. So everything is now segregated, right? And there's so many options even to host your applications. So improving the WAN environment for these applications is crucial. So basically at the end of the day, these applications are connected via the WAN itself. They're connected via the WAN. They're connected via your service edge, correct? They're connected via your service edge. So you will be connecting all of this over either MPLS connection or via VPN connection, right? So moreover, the increasing demand to migrate to cloud-based application further exacerbated bandwidth requirement on the WAN. So with this, basically what happened is the change in the application, the requirement of the applications was actually in the center because the businesses were looking for a better network. Businesses were looking for a better network, and that is why we were supposed to, or should I say the vendors were looking for redesigning the WAN. Okay, so let us just sum up those issues. Firstly, the cloud, the advent of the cloud, right? So there was no cloud a few years ago. It was just the on-premises. After that, everyone realized that there was a lot of dependencies on the ISP. There was a lot of dependency on the ISP. So everyone were dependent on the ISP in terms of their private links. Okay, the private link dependency was a lot. After that, so when they are actually when we are dependent on the ISP, then they become the basically a solo player in the market, right? So when they are solo players, like for example, there are few ISPs like AT&T, Verizon, and you can name them. Okay, so all of them, they are just few of them, handful of them. However, the customers are so many. So we have to wait based on their service fulfillment. Okay, so they take months together to lay a line, right? They take months together to lay a line. When I say lay a line, basically if you need a private link, then they take their own sweet time based on their based on the load of work, right? So the dependency on the ISP increased a lot along with the advent of the cloud. So this were a couple of issues that actually made the vendors rethink the traditional networking. So from the traditional networking, they moved towards the hybrid WAN. So what is hybrid WAN? So hybrid WAN is adding another underlay towards the connectivity. So now we have to understand what's the what is overlay and what is underlay. Any idea, folks? Underlay and overlay in terms of IT networking? Anyone here?
Yes. Underlay means like it's a physical data center, physical connectivity. Overlay means like a virtual connection over the underlay. Example, IPsec, VPN, GRE, like VXLAN. Yeah.
Great. Okay. So how can you apply the underlay and overlay towards the WAN side? Any guesses? Okay. So basically underlay is your end-to-end connectivity. So here end-to-end connectivity could be anything. For example, whether it's a private link slash MPLS, L3 VPN link, okay, or whether it is a plain and simple internet. Okay, The best example for the underlay and overlay is we connecting to our company, right? When you're working from the home. So basically, when we work from home, so what we do, we open up our laptop, we connect to the internet. The reason why we connect to the internet, because we have to reach to the office network. We have to reach to our office network. So that is our underlay. So underlay is actually the carrier. Without the underlay, you will not be able to reach your desired destination. Okay. The overlay is your uh, is actually your protocol, or should I say application, or any other should I say layer, which is going to take you to a specific destination. For example, in the case of we connecting our laptop, so the protocol that we use is IPsec, which is a VPN tunnel, correct? And how do we get that? We how do we establish it? Most of the times we establish either through the secure client, or we establish it through our Juniper Pulse, or we establish it through Zscaler. Okay, so this is the should I say use case, or should I say this is how the underlay and overlay works. So let us apply the same thing towards our WAN. So our WAN has MPLS connection and internet connection. Okay, so let me now move towards the next slide. So everyone were using the MPLS connection, and everyone were dependent on the ISPs. Then they thought, let us now have an alternative. As the applications started increasing, they started having, or should I say, looking for the alternatives. The next best alternative was plain and simple internet. On top of the internet is a carrier. Now they're supposed to have a overlay. They were supposed to have a logical path towards their destination. So what they started using? They started using the tunnels like IPsec and then your GRE, right? And then your get VPNs. All types of VPNs then came in the picture. And these secondary path, or should I say these paths, were treated as the secondary path. So with the MPLS, there was a growing applications. The applications were growing and they had a single path. So they started using the multiple path strategy. Okay. So this multiple path strategy was very fruitful till few years ago, right? Because the internet was very cost effective. The internet was very cost effective, and all that they had to do is they had to run few protocols. They had to run few protocols, and those protocols were also very secure. However, the applications then evolved in such a manner, with the cloud as well coming in. This model also was not sufficient. Okay, this model also was not sufficient. So with this, the reason why the model was not sufficient, because people started moving towards cloud a lot. They started moving towards cloud a lot, and the advent of your software as a service and infrastructure as a service increased a lot. So with this, the branch and campus users also were geographically separated in a different manner. And people started using different types of devices as well, right? And now you have what? You have some small, or now you also have your spectacles, which are smart, right? So do you people know? So there are smart spectacles as well. Meta just released a smart spectacle. However, it was a blunder, but there are many other vendors who are actually selling the smart spectacles. So basically you can take up the calls and then you can go look for the navigation, everything via the spectacles itself. Do people know that, folks? Do people know it?
No, sir.
Okay, great. So one of the disadvantages, of our hybrid WAN was basically we were connecting. Okay, we're connecting one via the direct cloud, or should I say direct link, and one via the MPLS link. The MPLS links were very fast. However, the internet links were very slow because they had their own limitations, right? So now we were looking for something which was exactly, or should I say, which was supposed to be very fast in terms of both the connectivities. So with this thought process, the software defined networking was introduced. So the software defined networking was introduced not just for the WAN, it was introduced for the data centers. It was also introduced to the branches. Okay. So let us just quickly go through how did the traditional networking move towards the SDN, software defined networking. So for the data center, the traditional way we used to use was 2-tier and 3-tier, which moved to the ACI. For the WAN, we had MPLS, L3, VPN. We also very fondly use MPBGP in it, and that moved towards the SD-WAN. And then for the branches, again, the branches also had 2-tier and 3-tier. That moved towards the SD access. So for each and every requirement, uh, many vendors introduced software defined networking products. Okay. Now we are focusing only on Cisco here. We're focusing only on Cisco. We are not focusing on Juniper or VMware, which is now Broadcom, or Fortinet. We're not focusing on any of the other vendors. We're just focusing on Cisco. That is the reason I'm just providing the names of SDN products from Cisco. Okay. Multiple vendors created, or should I say, introduced their SDN products based on this requirement itself. Okay. So products for data center, products for WAN, and products for the branches, which included the data center. So basically, this is a combination of two, data center and the branches. Fine. So now let us focus just on our requirement here, or should I say our discussion of the day, which is WAN. So we understood why we had to move from the traditional networking to the software defined networking. Okay. Now let us understand what is SD-WAN. Okay. So before understanding what is SD-WAN, let me tell you a small story of exactly what did Cisco do on this. So Cisco had to bring in products for software defined networking. So Cisco is very good at it is very good in actually purchasing other companies. So basically Cisco looks for any startup. It looks for any startup that is doing good and it buys that company. The same way, I'll give you a few examples. Meraki. Okay. The second one is Viptela, which we'll be discussing now. I'm just giving you two examples here. There are multiple examples like this. So Cisco, if Cisco cannot break through on a specific business, what they do, They show their muscle power. They just purchase the startups that are doing well. Okay. So the same thing they did with the SD-WAN. So they had a big breakthrough with the data center. So they had the Nexus devices and then they bought in a controller and they got the ACI done. So for the HD access, they had already their routers and switches. They bought in a controller just like the data center ACI. They bought in a controller called as DNA Center, which is now called as Catalyst Center. They already had a security product called as Cisco ICE, and then they wrapped it in a product called as HD Access. However, with SD-WAN, they were not able to crack it. So they had the way how they are supposed to do. However, they liked this company who had done, or should I say, that was already in the market. So the company was already in the market selling the SDN for WAN. So they took over Viptela. They took over Viptela, and till 2023, till 2023, it was this particular product was called as Cisco Viptela SD-WAN. Okay. Now comes the twist, or should I say, after purchasing. Now this is all business I'm talking about. Okay. So after purchasing Cisco Viptela, what they did, they had Cisco Viptela. Okay. Now they had to integrate their iOS. They had to integrate their iOS XC. They had to integrate their iOS XR. Okay, because those were their CE products. They had to integrate it because the Cisco has huge number of customers. They have taken their products already. So what are they supposed to do with the existing products? So what they did, Cisco comes up with a complete solution. So what does Viptela comes up with a complete solution. What is the solution? The Viptela has 3 controllers. Okay. Viptela has 3 controllers. The first controller is your vBond. The second controller is your vSmart. And then the last controller is your vManage. So we'll discuss about so what is the function and all in the in next few minutes. So we'll just understand how exactly Cisco merged its devices into a third party device. Okay, because Viptela is what? Viptela is a third party. They purchased the product from someone else, right? So they acquired the company. The word that I'm looking for is acquired. They acquired some other company, right? So that company's product is Viptela, and it comes with 3 controllers. Along with that, it comes with one device, which is called as Viptela Edge or vEdge or virtual edge. That is like a smart device, which actually connects to the existing devices, existing traditional devices. So basically, the technology was to connect a different piece of software to your existing device. Connect the different piece of software to existing device so that your device behaves as per the requirement of the new software. Does that make sense, folks? Any questions till now?
Sir, can you please repeat the last statement, sir, once?
Okay, you want me to repeat the last statement?
Yes, sir.
Okay, so how does Viptela's SD-WAN work? Okay, so I told you that Cisco acquired Viptela, correct? Now, Viptela's product contained three controllers. The first one was vBond, the second is vSmart, the third is the vManage. So these controllers would be hosted in some server because these controllers are all virtual VMs. Okay, these are all VMs. Okay, these are all virtual devices. So these VMs would connect to one of the product, or should I say one of the, or should I say the continued part, the other part of the product, which is called as vEdge, which is hosted in the branches. The vEdge is hosted in the branch. So this vEdge can be either a VM or a hardware. It comes in both the flavors. So this particular vEdge, Viptela Edge, is the same code. It's the same image from the set of images of Viptela. And this vEdge is supposed to connect to the traditional routers. So when it connects to the traditional routers, so you can actually manage this traditional router from your data center itself. Okay, does that make sense now?
Yeah, yes, sir. Yes, thank you, sir.
Cool. So now let me dwell it a little bit more. Okay, so what is the importance of you managing the devices from a single GUI? Okay, firstly, you can do the analytics. You can actually connect all your security stuff to your GUI, or should I say your controllers, and then you can enhance the security. Secondly, the monitoring. You can monitor your entire network from a single pane of glass, and then you can do the operations like configuration. So basically, in the traditional networking, if we had to do the configuration, we had to log in into each and every device separately. But with the SDN, the concept was moving towards a centralized control plane. Centralized control plane, and most importantly, management plane. Cisco was successful in getting it done with the data center. It was successful in getting it done in the branches. However, with SD-WAN, it found lucrative to actually acquire Viptela, which was doing the same thing, right? Which Cisco wanted to do, so it acquired. So Cisco acquired, and the next point is after acquiring, Cisco slowly started uh, integrating its piece of code with the Viptela's product. Okay, so by 2023, they completely integrated it. Okay, so how did they completely integrate? Now we can, okay, they started very slowly with adding in the 1000V for SD-WAN. So they introduced 1000V for SD-WAN. They introduced ISR for SD-WAN. So these images were directly connecting with the controllers, the vManage, vBond, and vSmart. Okay, so 1000V has two different flavors. The first flavor is non-SD-WAN, the other flavor is with SD-WAN. ISR also has two flavors, the one with the SD-WAN, the other with the non-SD-WAN. So they introduced the SD-WAN images. And then they requested, or should I say, they gave an option for the customers to either replace the existing customer edge on the branches to either the 1000V or ISRs for the SD-WAN, or they give an option of using the Viptela edge or the virtual edge. Okay. So after 2023, they completely merged the Viptela's SD-WAN and renamed it, called as it is now called as Cisco's Catalyst SD-WAN. They've also renamed the names from vManage, vBond, vSmart to now they are called as manager, validator, and the controller. Along with that, they also introduced multiple analytics. For example, you have your AMP, advanced malware protection or prevention. You also have your other security features as well. Along with that, they also introduced 8000V, Catalyst 8000. So this is the new series of hardware and the uh, virtual image. So this was specifically introduced for your WAN. Okay, however, they have multiple products that can also be used in the data center. So with SD-WAN, so this was the latest product that was introduced. Now you can use the Catalyst 8000 for your traditional networking and SDN with a single image. So Cisco had introduced different images for SD-WAN in the 1000V and ISR, but with now this is the next step that they took, right? So they are progressing slowly. So now they have introduced 8000, which is a single image that can be used for both traditional networking as well as for the software defined WAN. Okay, all good, folks.
Yes, sir.
Okay, any questions? Okay, I take it as a no. Fine. So this is the high level of the SD-WAN. So this is the high level topology of SD-WAN. So the high level topology is you have your controllers. Okay, you have your controllers connecting to. So these are your controllers. Okay, these are your controllers. They are connecting to your cloud. They are connecting to the data centers. The cloud contains multiple stuff. For example, infrastructure of a service, software as a service. Okay, you also have your virtual data centers as well, which is your private cloud. You can do automation with the SD-WAN. You can also do the analytics, and you can add in the security based on your requirement as well. Okay, so this is the high level view of SD-WAN. So now let us quickly look at the difference between the traditional networking and SD-WAN. The traditional networking was like this, plain simple. As we remember, we had a data center, we had an MPLS connection, we had branches, and then the users, right? So we also had internet connection for the secondary path. However, with SD-WAN, everything has now changed. So what has changed? What has changed is you can now have multiple paths with just the dual connection. So basically you can have some secure links and there is a equal connectivity speed, equal connectivity without any jitters, without any data loss, okay, or without any latency. So how is this achieved? This is achieved based on the tunnels that the SD-WAN offers. Okay. So let us dwell a little bit more. So I mentioned that what are the advantages of SD-WAN? I'm just expanding on them. Okay. You can deploy SD-WAN anywhere. You can deploy it whether on premises or the cloud or in the multi-tenant. Okay. So advantages of it is you can do the automation. You can see the network insights. You can include machine learning, very important AI. It's all AI nowadays, right? So it's all AI nowadays. So you can integrate your AI intents. Okay. Then you can also do the programmability based on your requirement for the automation. Okay. Next, services. So you can put you can actually use any type of service, whether it's a multi-cloud, multi-layer security, analytics, voice, multi-domain intent-based networking, IBN, intent-based networking. So what is intent-based networking? Intent-based networking is actually designing your network based on intent. So what's the intent? So for example, I want a specific application to run as I need. For example, uh, I need XYZ application to have this much bandwidth. I want that application to be the priority over the other application, and I want my network to change when that application actually um, is actually in production. When I say actually in production, when this application is actually communicating, right? When there's a live traffic of the application. So based on the application, the network's design, or should I say the network's traffic will change. So that is my intent. So that is my intent. So basically intent is actually a desire. My desire is to do XYZ, and my network will actually work based on the desire. Okay, so that is called as intent based networking. So in terms of SD-WAN, the desire for any business is to actually customize their own application based on their requirement. Does that make sense, folks? Yeah, great. I understand. I understand these are all new technologies. Should I say new terminologies that you people are listening for the first time? However, try to grasp as much as you can, and you can ask me questions whenever you feel like you've completely missed it. Along with that, any transport. So basically, SD-WAN can take up any transport, whether it is a satellite, internet, MPLS, or whether it is your 5G connectivity. Okay, so there is also 5G connectivity that can actually be used for your private links. So basically, MPLS is one type of a private link. Even 5G is also the other type of a private link. So if you are not looking for something which is very uh, which is not very costly, then you can also go for 5G connection, which is a replacement for your MPLS. However, the most effective, cost effective is your internet, correct? You just take the internet and then you run your VPNs on top of it. And lastly, any location, right? So this you can actually implement this in any location, whether it is a branch, whether it is a co-location. What is a co-location? Co-location is your hybrid model. What is hybrid model? So basically on premises plus cloud. Okay, which is most common network nowadays, right? This is the most common network that we see. So we don't see cloud only, we don't see on premises only. We always see the hybrid network on premises as well as the cloud. However, there are different types of the different types of again categories with the cloud, as I mentioned. So we'll be discussing about that in a brief in the next slides as well. Okay, nextly, what are the features? So we already discussed few. Now let us discuss them in detail. The features of SD-WAN, firstly, physical or virtual secured routers. So basically, you can have the security that is required for your wide area network. Okay, and you can implement whether it's on a hardware or whether it's a VM. Next, redundant management in the cloud or on premises. So you can have multiple management options. So which means that you can include multiple vManagers. You can include multiple controllers. You can include multiple controllers for the redundancy. The next one, zero touch provisioning. Now, this is the most important aspect of SD-WAN, which I have not touched till now. What is zero touch provisioning? Zero touch provisioning is actually, before that, let me take a step back. In the traditional networking, I'm sure you people have done this. In traditional networking, if a device was supposed to be installed, the process was what? The process was you had to ship the hardware. Before shipping the hardware, you were doing the minimum configuration to the hardware. Okay, you were shipping it. The person would then the on-site contact would connect or collect that particular hardware. He will cable that hardware, and after cabling the hardware, then he will give you the remote access. And then you would do the other part of the configuration wherein you would be running the dynamic protocols. You'll be running the VTY connections, right? So that you can then access them via the SSH. So all of that was a manual process. All of that was manual process. However, with the zero touch provisioning, there is no need of any manual process. All that you have to do is you have to do your minimum, or should I say your basic bootstrap. After that, the device itself will get configured automatically by establishing the tunnels. You don't have to configure anything apart from the bootstrap. That is called as zero touch provisioning. So you're going from 100% manual configuration to just like 10% of manual configuration. The rest of 90% is all automatic configuration, and who takes care of it? Our controllers will take care of it. The vManage, vBond, and vSmart. So this is the most important, or should I say most frequently used feature of SD-WAN. And you'll be hearing this, or should I say you'll be asked about this a lot in your interview questions, which we'll be discussing in depth in our discussion in our live classes. We'll have separate labs for this, and we'll be in depth understanding each and every step on how it is going to work. Okay, moving towards the next one. The next one is separation of management control and the data of scaling. So basically in our traditional networking, what was the process? So basically there was a hardware which was managing the entire plane, data plane, management plane, and the control plane. It was all confined to a single hardware. Does everyone agree that there was one device in the traditional networking? If that device is down, the device is down, right? If the device is not running the protocol, then the device will not communicate. If there is an interface that is not configured, the device will not communicate. So that was all specific to the device. And if we have to make any changes to it, we have to log in into the device. However, with the SD-WAN, and all the planes are separated so that we don't have to log in into the device itself. We can manage the device via the controllers so that the device does not have the control and management plane. All that the device has to do is the device has to do the L1 connectivity by passing in the data plane. All the device has to do is actually do its L1 connectivity, and everything else, the L2, L3 and all is configured by the controllers. Next, choose choice of topologies with a point and click. So basically, whichever type of topology you want, you can actually choose it, as we already discussed about it. Flexible connectivity, we already discussed it. Secure segmentation support with VPNs and VRFs. So basically, can with SD-WAN, I just touched a little bit about the VPNs in the zero touch provisioning. So SD-WAN just works based on the VPN. So one thing you have to remember, the VPN in SD-WAN is actually the VRF. And I'm not very sure why Cisco uses the term VPN when it is actually VRF. Whenever you hear the term VPN in SD-WAN, it is VRF, virtual routing and forwarding. So there are multiple VRFs that are created with the different routing tables per the VRF. So one VRF is what? A virtual routing and forwarding. So basically it is one virtual router. And that virtual router will have its own routing table. So basically SD-WAN will create multiple VPNs, which is what? Which are actually the VRFs. And these VRFs will run a protocol like BGP called as OMP, Overlay Management Protocol. We do not run MPBGP in SD-WAN. We run Overlay Management Protocol for the SD-WAN requirement. You can absolutely run BGP. You can absolutely run OSPF for your traditional connectivity. However, for the connectivity between the controllers and your WAN edges, okay, and your WAN edges, the routers in your branches, okay, so they are going to communicate via a new protocol which is specific for SD-WAN called as Overlay Management Protocol. Okay. Next, complete visibility from a single pane of glass. So as I mentioned, you don't have to log in any of the device. You just log in into the vManage and see how you have to configure what. It all depends on your intent. Correct? You can configure based on your requirement. You can configure based on the hardware that you have. For example, you have just 1000 series. You can configure just 1000 series with a single click of templates, which we'll be discussing. We have a separate discussion for a couple of weeks with templates, how to configure your devices. Okay. Next, application aware routing. So this is what we were discussing till now. So we did not use the word application aware routing. Now we are using it. So making the changes to your network based on application is called as application aware routing. Your routing will shift based on the application. So we have a lab for this, which is a very in-depth lab, and you people also can take this up. Okay. Next, data and control plane security with IPsec and DTLS tunnels. So these, so what does our VPN tunnels are? The VPN tunnels are IPsec, and what are these tunnels exactly? These are DTLS and TLS, both types of tunnels. We'll discuss more about it. So just remember that the tunnels that are formed would be on IPsec, and this IPsec tunnels are of DTLS and TLS. Okay, next. optimization for our software as a service and infrastructure as a service, which we already discussed. Multi-layer security also, which we discussed in a very high level. Okay, so you can you can integrate your security with advanced malware prevention. You can also include your traditional firewalls. You can also include your traditional IPS. You can also include URL filtering. You can also include Cisco's umbrella, right? So this is also one of the security products from Cisco. You can also include the Cisco umbrella over there. Great. So before I move ahead, does anyone have any questions? All good, folks? Great. Okay.
Yeah, good, sir. All good. Yeah.
Okay. So I think let's give it a pause today, and we'll start up this new topic in our live training next week. Okay. So thank you for joining, folks. Um, and I hope you people connect us for the next week. Thank you.
Thank you, sir.